astounding seeing the pyramids and what they do. And I'm hoping I can add something to understand, for example, how they became covered, what was going on at that time during the Ice Age. This is my website, one of them. Let's see. Okay. So here we have the Pyramid of the Sun. We're looking, as I understand, this is the north face. And on the north face, east and west faces, the soil that's covering it is maybe 1 meter deep and gets less deep as you go up. But on the south side, it's much deeper. Sam told me that it's up to 10 meters or more there. So this would indicate, well, my theory is that this was buried by waves of water coming from the glacial ice sheet, which would have been to the north. And the fact that the sediments are deeper on the south is exactly what you'd expect for a wave coming from the north, because the south is sheltered, so sediment tends to collect there. Now, for sediment to go this high to the top of the pyramid and tops of these hills here, we're talking about huge waves, biblical proportions. And there's myths from all over the world that tell of the flood. Geologists may have trouble believing this because they don't really have, in the past, haven't had a model to explain how these waves would be generated. And for my PhD work, I studied the Ice Age period, and one of the things I was working on was the flood. And I will explain this mechanism. Now, the period, here we have some dates that have been done on the pyramid for dating radiocarbon dates. They say that the sediment generally is at least 15,000 years old. This is from the State Institute for Agropedology. But actual radiocarbon dates that they've done here in the Institute have here 24,800 carbon-14 years and 29,200 carbon-14 years. And to get to calendar years, you have to add some thousands of years because the carbon-14 scale always gives younger dates, and they calibrate to see how much to add. So we're actually talking, if you go to the higher one here, you get up to around 34,000 years old. And let's take that as the age of the pyramid, because this was, as I understand, a pretty good date. It was found under a block, so from a leaf, I believe. So it seems that may have gotten there when they were building the pyramid. So we'll go back to this time, what was happening at that time. First of all, the trees were all different from what you see. We have currently deciduous trees, but back then I looked up to see what it would be like. There was a lot of spruce. I think this may be spruce. I clipped it from the bush in front. Scotch pine, fir, Swiss pine. We also had some birch and grasslands. So trees that you see further north. The temperatures were perhaps 10 degrees centigrade cooler during the Ice Age. Trees like maple, elm, oak, birch, and poplar were very few. And this is probably most of the trees you see here are these types. This is a graph goes back 60,000 years. It shows radiocarbon excess. What this means is they chart what they would expect the radiocarbon to be, the radiocarbon dates. And if they deviate a large amount from the calendar dates, they say, well, there's excess radiocarbon. It makes it seem younger. But that's actually a measure of solar activity, because the more radiocarbon in the atmosphere, how it gets there is through solar cosmic rays in the atmosphere. So times when there was a great excess, like here, look at this. This was a 6,000-year period where radiocarbon was going up. It's the biggest increase we've had. Well, there was a very large one here, 58,000. But in the last 50,000 years, this was the biggest. And I'll show you a graph in a moment. It shows beryllium-10 went way up, huge peak, biggest one in 50,000 years. Beryllium-10 is produced in the atmosphere from cosmic rays, galactic cosmic rays. So this indicates something was going on from the galaxy, a big cosmic ray event, and the sun. The sun was extremely active. We're talking about much more active than today. If we go back, to give you a comparison, go back to this little peak here. You see this. This is about 13,000 years ago. This was about a 200-year rise of radiocarbon due to solar activity. During this period, the sun was about 50 times more active than today. And we had a mass extinction at that time. All the large animals in North America, Pleistocene animals, became extinct, leaving only small animals. And here in Europe, you also had a lot of mammoths that became extinct. So, by comparison, this was much bigger event. Now here we are with the pyramid, about 34,000 years. So this event had already occurred. By the way, Neanderthal man became extinct here. And this is with the latest data. The last few years, they finally said, yes, there's a definite extinction, that he didn't survive past here. I had said years back, about 2007, that if Neanderthal man had become extinct around this time, it was most likely this event that did it. And at that time, they still had dates as far forward as here, so they weren't quite sure where it was. Now they pretty much nailed it that it's right here. And that makes sense, because the levels of solar cosmic rays from the active sun on their surface would have been lethal. And one possible function of a pyramid in tunnels would be to get away from the radiation. So this could have had a very practical aspect in that sense, besides all the other things, the healing aspect, and so on. These arrows indicate times of rise of carbon-14, so you expect increased solar activity at these times. Also, I'd like to mention that this scale is very accurate in terms of time. Tree ring scales go back to about 13,000 years ago, so we go back about this far, tree ring scales. This is from the Cariaco Basin. They count the barbs in the sediment. This is an ocean sediment core. And as the seasons change, it makes a different color in the core. So they're able to count the years back. So it's almost as accurate as tree rings. And so this Cariaco Basin record is the most accurate chronology that we have going back this far. did a study of tracks on Apollo spacecraft windows. They looked at pits and they counted solar flare tracks in the pits. And they concluded that the solar flare rate was much higher in the past. They could actually make a record going back because there would be craters due to micrometeorites hitting the window, and then on top would be another crater and another crater. So they knew which craters came first and which later, and they were able to get this record going back in time. And you see that about 15,000, 16,000 years ago, the solar flare track production rate, or with solar activity, was about 50 times higher than it is today. And it came way down. So here we have the end of the ice age about here. So there was some big event, and this could be even pushed this way a little bit. This scale is not that accurate by counting the date the craters. There it is. Covering up something there. Anyway, I think what I was trying to say there, that covered up, is that we're looking just at this recent event during the period when we had that mass extinction. But actually, you had other events like this. It's just the cratering, if you look at the most recent solar activity event. The sun is something that gets very aggravated at times. And the question is, what aggravates it? And I'll get to that. So this is a map of the ice sheets covering the Earth during the Ice Age. You see here the North American ice sheet is the biggest. And here you have the European ice sheet. And this is the polar cap. Here's the Antarctic ice sheet, much bigger today. You have a little in Australia, South America. So here Bosnia is right around here. I'm guessing it was about 500 kilometers from the edge of the ice sheet, so it was pretty close. Now, what happens when you have ice and suddenly the sun gets more active and starts sending coronal mass ejections? Have you heard of the term coronal mass ejection? And another term they use is solar proton event. The solar proton event is when the cosmic rays come very quickly from the sun. They can come in a matter of hours, or even less than an hour to be here. The coronal mass ejection is actually a ball of plasma travel. It can take days to get. If you have a real big solar event, it can actually defeat the Earth's magnetic field. And actually, this event here, at 40,000, 41,000 years ago, you had a geomagnetic reversal. The Earth's magnetic poles actually reversed for 400 years. So that shows you how major was that event. We had a geomagnetic excursion, which means that the geomagnetic pole went towards the equator around 14,000 years ago, but not a reversal. So this was a really big event there. So when you have the heating of the ice sheet, there were times where the climate, even during the ice age, warmed up tremendously. You would have gotten melting of the ice, and it would have formed lakes on the surface of the ice sheet. And not only at the edge of the ice sheet, you would have gotten meltwater collecting big lakes at the edge of the ice sheet, but also at high altitude. This ice sheet is up to 2 kilometers, 3 kilometers high in the middle. So imagine what would happen if a dam that was holding this water broke somewhere in the middle of the ice sheet, and this water started pouring down, getting more and more momentum. And then it hits other lakes on the surface and triggers them. You get a domino effect. And by the time this wave gets to the edge of the ice sheet, it's perhaps half a kilometer high, and maybe going 200, 300 kilometers per hour. And it could be maybe 500 kilometers long, maybe 1,000, we don't know. Because as it comes down, it spreads out. And then once it hits there's water at the edge of the ice sheet, you can completely jettison the lake, and that would add more water. And this will keep going as what I call this a continental glacier wave. It can sweep across 1,000 kilometers of continent, even going to the ocean. And at this time you had ice covering a lot of the ocean, so the wave could actually skitter over the ice and end up going very far out into the ocean and dropping material, sediment from the mountains regions, from more continental regions. And this explains what are called Heinrich events. Heinrich, named after Heinrich, he found debris from continental regions in the middle of the ocean and couldn't figure out how it got there, because usually you expect calcium carbonate from shells. And here were certain bands of suddenly you got this rock-type material deposited. And he was thinking, well, maybe you had icebergs floating there and somehow we melted and left it. But one fellow said, yes, but this material was deposited very quickly. So quickly it actually crushed the sea life under it. And I'll show you in a minute some graph that shows when these occurred. These are examples of floods, gigantic floods from the ice sheet. So here is a picture of a coronal mass ejection. I guess I'd have to press it again. Same button. Do I press on the computer? It's a movie. The one I wanted to show is a movie of the coronal mass ejection. There, that's it. It's a movie. We have to do it manually. It's coming now. I think it's coming. Okay, well, we're going to see. I'll just tell you what it is. It's a picture of a plasma breaking away from the sun, coming out all the way into the earth, and it energizes the magnetic, it gets caught in the magnetic field of the earth, and these particles cause aurora displays. In fact, some people at Los Alamos, Barat and his group, they found the pictures that they draw, the petroglyphs they're drawing on rock. Some of these stick figures, they believe, represent pictures of auroral displays in ancient times, indicating that the sun was more active. People were seeing these, and they were generally as if they were painting what they were seeing towards the pole regions. In fact, it was so big, it could have defeated the Earth's magnetic field temporarily and allowed the coronal mass ejection then to actually contact the atmosphere, produce a cascade of particles, electron cascade, that when it reached the Earth's surface, trees could actually turn black. The bark would be carbonized. In fact, even the trunks carbonized. And in fact, I did some studies of mines in Greece where you find lignite. Carbonized material has been shredded up and deposited. So this event, coronal mass ejection event, conflagration, would occur immediately before a flood event, because then once everything is heated up, it produces a flood, and it would actually grind up trees, carbonized trees, lignite would deposit in any valleys, along with bones of animals. In Siberia, we find the parts of the animals are preserved because of the cold temperatures, the tundra. preserves the parts from decaying. So you have not only the bones, the tusks of the animals, but also entire carcasses. And they find ice mixed in with the bones and the sediment. And this is exactly what you'd expect from a wave coming down the ocean, because it would have ice mixed with the cold water. So this would have overtaken animals by surprise. In fact, in Alaska, they found mammoths that were eating daisies or whatever that was in their stomach. And so it happened so quickly while they were eating. It was probably in the spring or summer when it occurred. And probably the cosmic rays from the sun help preserve them from decaying. So it's sort of like instant pasteurization. They caught it out. And the large animals, like mastodons, they didn't have any place to hide. The small animals could sense this and they would go into the holes. By the way, I think we all have the ability to sense cosmic radiation. It would produce flashes of light. Then you would start seeing flashes of light. Could be bluish or white. Astronauts reported this up in space, this phenomenon. They found it correlated with cosmic ray events. And actually, I experienced some the other day, a few weeks back, and I thought it was unusual. And also, about the same time, the TV flickered, and sort of like as if a cosmic ray had gone through it. So I thought, well, I better report this on one of my news postings, because we're very carefully watching the galactic center now for an outburst, because there's what's called a G2 cloud coming in, and we're concerned whether some material might get ripped off and engulfed by the galactic core and produce galactic core explosion. So I thought it best to report this, and I said, I don't know if this means anything, but this is what I experienced. And all sorts of people wrote back that they had similar experiences, not just at that time, other times. And so it seems like fairly, a lot of people have this experience. Maybe people here have had it. And also, it was found that the cosmic ray, there's something like 8 out of the 20 cosmic ray detectors went offline about that time that I had seen the flicker on the TV. A lot of them in the polar regions. So it seems like something might have really happened at that time. But not to worry right now. I mean, everything is okay, but you never know. These things can take you by surprise. So here's what a glacier wave would look like as it comes down the ice sheet. It gathers energy and really takes off. So here you have the mechanism how waves of immense energy, we're talking about one Hiroshima bomb of energy being packed every meter of wavefront. I mean, this is very energetic. Can completely reshape the surface of the Earth for thousands of kilometers southward. And all of this topography you see here is a result of these waves. They're meters deep in sand. If they could export sand from here, they'd be rich if there was a market. But you see a great difference between Bosnia, for example, and Greece, much further south. There you see more of the rock, bare rock. And the sand is more in the valleys, but you do see sand deposits perched at higher altitude. Here's some of the animals that went extinct at the end of the Ice Age. These are some websites of mine. This is my book, Earth Under Fire, where I describe this. This is my dissertation, PhD dissertation over here, which I put on CD and updated. It's more technical. This has a lot of myths about the flood and conflagration. I put the whole thing together as to how this event occurred at the end of the Ice Age. Here's a map, another map of the ice sheet looking down from the pole. Here's Alaska. You find a lot of animal carcasses preserved in the tundra here. Siberia. Here they find mammoths, mastodons, with just the bones because they're not preserved. This is North America. Here we are, European ice sheet. So Bosnia is somewhere here. This is from central Alaska. And one characteristic of these deposits is that the heavier material will be at the bottom and the lighter material further up. Like at the bottom you find gravel and even gold, because gold being heavier. That's where they find the gold, is at the bottom. And they do a lot of gold mining in Alaska. So as you go up, you find, for example, the skin of animals, carcasses that have not decayed. You'll find them more up here, whereas the bones, heavier things you'll find down here. This is a picture from Siberia. You see the muck. This is frozen muck that melts in the spring. And you see the tusks there. This is an aerial shot of drumlin fields in North Saskatchewan, Canada. These, these are drumlins. These things shaped sort of like a chevron sign. They're hills that are about 20 to 30 meters in height, 400 to 600 meters in width, and about 1 to 4 kilometers long. And the geologist who was discussing this concluded that the waves had to be much higher than the height of those drumlins. So we're talking about at least 100 meter high waves, traveling at enormous rates. And this is sediment that piles up as it goes. For example, one drumlin field in central western New York State contains 10,000 drumlins. And these are most obvious when you're flying over the airplane. Here's Scablands, eastern Washington. The canyon here carved by water flowing at tremendous speeds. These waves greatly sped up the rate of transformation of the planet. So things that geologists would have assumed would take hundreds of thousands of years, maybe millions of years, can happen in a matter of thousands of years. Here's another shot of Scablands in eastern Washington. They're very close to the ice sheet, where the ice sheet was. Here's the Columbia Gorge in Oregon. This was full of water, traveling very high velocity towards the ocean. And Scablands is over the hill here in this direction, towards Washington. Here's a map. Shows you, here's Mount Rainier. Here are the Scablands. Montana, Idaho. Here's the Columbia River. Here's the ice sheet. See how close? And then the Snake River here. And here's a shot of the Snake River Canyon in Idaho. And they find this in Nebraska. It's called Agate Springs Quarry. These are all bones of animals that are left in the deposits. Here's Grand Canyon, Arizona. Again, this would have been full of water these waves. They travel great distance. So things that you would expect take millions of years, a lot of this could have happened just in the last few ice ages. I did some study in Greece, a place called Megalopolis, which is right here in Peloponnesus. And there's a basin that's surrounded with mountains. They mine lignite here. This plain actually is a flood deposit. You had these huge waves extending down as far as Greece, and they would top over the mountains, stripping all the trees. Greece was loaded with evergreens in those days. It just pulverized them and dumped that along with the sediment here in this valley. This is one example. And today they're mining this. So you can think of this as the floods of Atlantis. The results are being burned for lignite. And here you see this dark area. This is lignite. And there's the power plant where they're burning it to generate electricity. I went there and I did close-up examination, took samples. I did some radiocarbon dating and sent some samples for radiocarbon dating. They came up with a date of at least 45,000 years. The ones I sent. So this may be related to that very large event we showed earlier. And you find other deposits through Greece. Here on this island of Evia, up here, Kozani, so on. You find these basins where they're mining the lignite. And always the lignite's covered with sediment. Well, see, these waves came and they're recurrent because after these lakes discharge, they still can melt and accumulate more meltwater, and then you might have another discharge event. So it's multiple waves. It's not just when you hear about one flood, but actually these were many floods, and they occurred throughout the Ice Age. Also, this whole area here, Larry says, is a big plain area. The way the geologist described it, that there was a lake there and that it gradually drained through this gorge into the sea. Well, how would a lake form if there was a passage to the sea? That's the problem. With this theory of the glacial wave, it explains this is a lake where huge amounts of water came all at once, created the lake, and over periods of months it finally drained into the sea. I went on a trip up here west of Larry's side, and you find sediments at very high altitude in the mountains, and you wonder how did they get there? The only way is to be transported by huge waves, just like this. And like earlier, I was talking about the lithic fragments. Heinrich found these Heinrich event horizons here in the North Atlantic. And here you can plot out the Heinrich events. They name them H0, H1, and so on. And they're dated here. This is a record that goes back 90,000 years. And here's the 40,000-year event. So you had Heinrich event 5 was associated with that, and then you had immediately as it was ending another Heinrich event. So these are indicating times of floods. If the pyramid was built here, you had many floods after that would have covered it. See the Heinrich events 3, 2, 1, and 0. Heinrich event 0 was about 12,500 years ago. Actually, probably started around 12,700, which is a flood date that's recorded in the archaeoastronomy records. This is a blow-up of some of these Heinrich events, showing how they match the climate profile. This is cold temperatures, and then down this way is warmer temperatures. This is the end of the ice age. So here would be several events that could have caused the fill, covered the pyramid. This graph I made by taking data from the rise of sea level, because at the end of the ice age, sea level was rising, and during the period when the ice was melting, this is right around 14,500 years ago, the rate at which the sea level rose really went way up. So you would expect a lot of flooding at this time. Also, this indicates the rate of glacial recession. So it matches, that's peak. And you had it subside a bit, and then it suddenly rose again. This is meltwater pulse V. And this occurred right at the end of the Ice Age. And that correlates with Plato's date of 11,600 years ago. Now, these flood events were very important to the ancients. They wanted to pass down the knowledge of this to us, the future, because when these events happen, it destroys civilizations. So, recorded history, people are reduced to living in caves in order to escape the events. They have to rebuild whatever civilization they had. There's indication, possible indication, what I saw in some of these specimens, that there was actual iron there, that was rusted, but iron is preserved in part of the rock. If that bears out, that would indicate whoever built the pyramids had machinery. Iron would rust very easily. It would just become powder after some hundreds of years, and then just dissolve. You would have no trace of it, but in this case, it was partially preserved in the rock. So if they had iron machinery, this would help explain how these pyramids, how the tunnels were excavated. I believe that the tunnels could have been shelters to escape from the radiation. And in fact, these rooms could have held many people. The fact it's a healing area, if they did have radiation damage, to go in the tunnels, they would have get healed. The fact it's a labyrinth, maybe they even had tools in there that if the flood had closed off the entrance, they could dig their way out again. And even in the pyramid, we see evidence that the tunnels go under the pyramid. Some work has been done. So they could even have taken shelter inside the pyramid. In fact, all of Visserco, from what I learned, it is literally littered with tunnels. These tunnels that have been excavated is just the tip of the iceberg. These tunnels could have held perhaps 1 million people. So this could have had quite an extensive civilization. It's just you don't see it because it's all under the sand. You might have to dig down 30 meters to find it. Here is the easiest place to uncover because the pyramid is so tall. It's the easiest artifact to uncover. And maybe geologists can then get interested. I mean, this should be a place where you have thousands of geologists trying to uncover this because you can find a whole civilization here. And it stands to reason because the climate was more of an invigorating climate here during the Ice Age, similar to northern Germany, Sweden. So one way they passed the information down was with the zodiac. The zodiac actually takes account of these catastrophic events.